So hello everybody, my name is Houssein Djirdeh, and today I want to talk about progressive web enhancements, specifically something called the purple pattern. Simply put, the purple pattern is not a specific tool or technology. It's a set of different techniques you can apply to your web page in order to make it load faster and load more reliably. So first and foremost, you want to push your most critical assets to your users, and you do this in order to try and render your initial route as soon as possible. The next thing you try to think about is try to pre-cache all of your remaining resources, as well as trying to lazy load all of your remaining routes. Now, before we go into the details of what each technique is, I want to take a step back and talk about mobile for a bit. I think it's safe to say that the vast majority of us in this room own a mobile device of some sort. Now, what we do on our mobile devices can change day to day, but year after year after year, we've only been spending more and more time on our smartphones and our tablets. So here's some data from ComScore, and it's actually the US data. I should have double checked and found Europe data, but I'm sure it also applies. But what it shows is it shows a comparison of unique visitor visits between mobile native applications and the mobile web. Now, as consumers, we tend to spend a lot more time on native apps on our phones than we do on the mobile browser. But you can see here that in terms of unique visitors, we're almost 3 times more likely to land on a mobile web page than we are a native app we haven't seen before. And that's huge. That just goes to show we spend a lot of time on the web, and just like Julian mentioned, it's changing than more than just desktop. It's becoming multi-platform. So how can we make sure that the users who view our web pages have a great experience when they view it on their mobile device, or any device for that matter? There are a few different ways, and we'll go through them in this talk, but I want to spend a little time talking about how the web works first. So when I open a browser on my mobile phone and type something into the URL bar and press enter, a request is made to a server somewhere. And after a certain period of time, the server responds with the content that the browser needs. Usually, this takes shape of an HTML document. The next thing the browser needs to do is actually parse the contents of the HTML file and find out what else it needs. So it submits a request for them and gets a response for that. Now, the web usually works in this sort of pattern. It makes requests and it gets responses. These external resources can be CSS files for styling, it could be JavaScript for dynamic content, it could be static images, for example. But the point I'm trying to make here is that with a typical web page, multiple round trips are usually needed for the server and the browser to interact. So let's say this is the HTML that the browser first retrieves on the initial request. You can see that there's a simple style sheet file as well as a JavaScript file being referenced. One thing we can do in order to help the fact that multiple round trips are being made is leverage something called preload. Now, preload has a syntax a lot of us, I think, are familiar with. It's a link HTML tag, and it has an href attribute that defines our actual file location. But we also have a rel attribute with the value of preload and an as attribute with a value where we try to tell what type of file we're trying to load. In this example, it's a JavaScript file, so we're saying as script. Now, what does preload actually do? Preload lets us tell the browser which resources it needs immediately after the page loads. In other words, we're telling the browser, hey, this is extremely important. Please download it as soon as you can. So what the browser now knows to do is to make that a much higher priority than the other resources it finds. You can use preload like we just did for resources in the head of your HTML document, but you're going to notice the most benefit if you're using it for files that are going to be discovered much later. A good example could be a font tucked deep in one of your CSS files. So you can use preload to preemptively fetch JavaScript files. You can do it with style sheets. And again, it's the as attribute that defines what type of file you want to preload. You can use preload for images, for fonts, for audio, video, and there's even more. Something else you can also leverage is something called prefetch. And it's very similar to preload, but the only difference with prefetch is that this is for resources that are at a different navigation route than what the user is currently on. So in other words, we're telling the browser, hey, the user might need this JavaScript file, for example, but at a different URL route. So try downloading whenever you can. The browser knows to download more critical resources first, and then it'll actually decide whether it needs to download this at a later stage. So using preload and prefetch in the head of your HTML document is kind of easy if you're building a simple static site. You just add link tags. But it gets a little more complicated if you're building a large web application or if you're using a module bundle like Webpack. Fortunately, if you are using Webpack, there's a tool out there to make it easier. It's called Preload Webpack Plugin, and it's built by Adi Osmani from the Google Chrome team. And what it allows you to do is it allows you to inject preload and prefetch tags for some of your chunks that get outputted or your major bundles. And all you need to do is add a few lines into your Webpack configurations file. And it's really quite straightforward. So can we use preload right now? Fortunately, Chrome, later versions of Safari, and Opera all support preload. With Firefox, it's actually partially supported now, where only cacheable resources can, but you can still use it for JavaScript files, for style sheets files, and so forth. With Edge, if I'm not mistaken, it's under consideration as for now. And hopefully that will change in the future. So another point, so we've talked about how preload and prefetch can be used to define some higher priority resources to the browser, but another important point of topic that I also wanted to talk about is something called HTTP2 server push. So HTTP2 essentially tries to provide a number of performance improvements over HTTP1, but the one we're focusing on here is purely just server push. So let's revisit our original scenario again. I'm on my mobile phone. I open a web app or a web page, and I type something to URL bar, I press enter, and the initial request is made to the server to get that initial HTML document. But this time, the server can not only just push that HTML document, we can also tell it to push some critical assets at the same time. In other words, the server is actually pushing resources to the browser before the browser knows what it needs. This can be extremely useful because we're cutting round trips. The browser doesn't have to go for a JavaScript file if we're giving it immediately. So one thing I didn't mention previously was instead of using a link HTML tag in the head of your HTML document, you can use link HTTP headers to achieve the same result for preload. And the format is really the same. You define your file location, you have the rel preload attributes, and you also use the as attribute to define the type of file. Now, a lot of hosting platforms and servers that actually use H2 server push, whenever they see this link HTTP header, they'll automatically try pushing those assets down the wire. A good example of a hosting platform that does this is Firebase, and it does it really well. So if you have ever used Firebase hosting, there's a simple Firebase JSON file at the root of your project where you can actually add configurations. If you add link HTTP headers on that file for a specific resource or for multiple resources, every time you reload your app, Firebase will push those assets down. Now, if you want to use link HTTP headers, but you don't want the server to push and you just want to use preload, you can add a no push attribute. And the result here is pretty much the same as link HTML tags. So here's some really interesting data by Jeremy Wagner. The link is down there. Unfortunately can't see it right now, but I'll send the slides out. I'll put it on the actual meetup. But what he did was he actually wrote a very comprehensive guide to H2 server push. And part of his article talks about when he actually ran some web page tests on a single web page, but with slightly different variables. So if you look at the middle right bar chart, the tallest bar, you can see the page load time for HTTP1 without any enhancements. To the right of that, you can see how page load time slightly decreased when he inlined CSS. And to the far right, you can see how the average page load time, average represents blue here, when he inlines everything. Now, if you're inlining all your CSS and your HTML or your JavaScript, you're obviously going to get faster performance because now server round trips aren't needed. But if you're building applications or even simple websites, that's not always the nicest thing to do in inlining everything, right? Now, to the far left, you can see how page load times are decreased when he just switches to HTTP2 without doing anything else. And that's what I mean by H2 actually having performance improvements besides server push. To the right of that, you can see what happens when he pushes CSS, and notice how the page load times is actually lower when he pushes only his CSS instead of when he pushes everything, which is to the right of that. And that brings me to a very important point. HTTP2 server push, you can run into the problem of pushing too many assets. There's no right number of files you should push down. It really depends on the type of application you're building, the number of assets you're trying to load. But something you need to sort of think about is when you're asking the server to push all the files down at the same time, your browser needs to install that or sets that as such a high priority and tries to download them at the same time. So you're going to get the most bang for your buck if you only push certain high priority resources instead of everything. There's also the issue of pushing unused assets. If you tell your server, hey, push this JavaScript file, but your browser is like, I don't need this, then you're just wasting pure bandwidth. And one other thing about server push is that it isn't really cache aware. So the browser has a cache, and it caches some files when it reloads them. But the server has no idea that the browser is actually caching those files. So if I reload a page and the browser already has it in the cache, the server is going to push it again. But we don't need it a second time because the browser actually has that file cached. We'll talk about a potential solution to this in a bit. So whether you use preload, whether you use prefetch or H2 server push, or a combination, it's important to sort of think about pushing critical assets to your users in order to load your application as fast as you can on first page load. So now let's switch gears a bit and let's talk about something I think a lot of us are familiar with seeing, and this could be when we're using the metro or if we don't have a data plan and we try to open a web app or a web page and we don't have a working network connection. So Julian touched up on this briefly, and it's something we can actually use to solve this, and it's called service workers. So service worker is a script that runs in the background of your browser when you actually view a web page. So how can I actually add a service worker? One way is you can create the file and write the logic yourself. Another thing you could do, which is most likely a lot simpler, is to use a library. One such library is called Workbox, and it's also built by the Google Chrome team. So you can install the CLI globally, and it's just a single command, generate SW, that creates a service worker file in your project. But when you run that command, you get a series of questions. And sorry if anybody in the back can't read this, but the first question is, what is the root of your web app? And then the next one says, which file types do you want to cache? You can actually say, I want to cache all file types, or I just want to cache JavaScript files, for example. The one after that is, where do you want to save your service worker file specifically? And the very last question, which we'll see in a bit again, is, do you want to save these settings into a configurations file? If you say yes to the very last question, the next time you run this command, it won't ask you this again. And that's why it's so useful. You just had that configurations file you can modify whenever you want. So now those commands actually just create a service worker file where you ask it to, but you still need to tell the browser how I can register this file. You can do that. One way to do that is adding a simple script tag in your index.html. The first thing you do is you check and say, hey, this service workers actually exist in my browser. If it does, you want to make sure you're registering the service worker after the window onload event. And the reason you want to do that is you don't want your browser to start registering the service worker when your window is loading because it's just contending resources. Once window onload is done, you can just run navigator service worker register with your file location for your service worker. And if you like, you can have console log outputs to say, hey, it's successful, or hey, registration's failed. But we've talked about how we can install a service worker file. We've talked about how we can register, but we still haven't touched up on what exactly a service worker does. So the very first thing you can sort of think about is an application shell. And like the name suggests, the app shell is the shell of your user interface that doesn't actually hold actual content. It's the header, it's the loading icons, it's the footer of your application. So what a service worker allows you to do is service workers act like a middleman between your browser and your server. and it can actually cache the HTML, the CSS, the JavaScript files that make the app shell. The reason why this is so useful is when I reload the page for a second time, your browser doesn't have to go all the way to the network to get those assets again. Your service worker can intercept that and say, hey, I have those files, here you go. So you're getting a lot faster repeat visit time, load times. So remember how the very last question Workbox asked was, hey, do you want to save this into a settings file? This is what you sort of see. It's a very simple export object. The very first attribute, glob directory, is where you want to, where your root of your app is. If you're using something like Webpack or a module bundler, you most likely have an output folder like this. Glob patterns is, again, the types of files. So you can use wildcards to define which types of files you want to pre-cache. swdest is where you want to save that service worker file. And navigate fallback is something you sometimes need to add if you're building a single page application in order to tell where the index HTML is. So the Workbox CLI is so useful because with a single command and in about 30 seconds, you can have a service worker file up and running. But the problem with that is every single time I make a change to my application, say I add a CSS file or I remove an image, I'll need to run that command again in order to make sure my service worker file is up to date and is caching the correct assets. So it probably makes more sense to, instead of installing it globally, to install it as a dev dependency and then adding it into your build step. And the reason why this is so nice is every single time you actually run a build, a new service worker file will always be generated. If you happen to be using a plugin like Webpack, sorry, a module bundle like Webpack, there's a plugin out there that can actually allow you to do the same thing. And there's another one for Gulp as well. And essentially, they're all exactly the same way in order to just easily allow you to generate service workers as part of your build steps. So the next thing service workers allow us to do is actually cache dynamic content. And as Julian touched up on this as well, because the application shell is essentially the shell, the HTML, the CSS that make up the surroundings of your app, but not really the actual data. So if we go back to that configurations file again, if we add a runtime caching array, we can actually define a set of URL patterns and then a set of handlers in order to handle the data that's getting back. So in this example, I'm saying, hey, whenever HTTPS yourapi.com is being hit, I want you to have a network-first strategy. In other words, I want the service worker to always cache the data every time this request is hit. But if my network fails, if I don't have a data connection or the server is down, I want the service worker to give me its data. So as a user, I'm always going to see data on the app. It might be slightly older. It might not be the freshest data, but I'm seeing something instead of not seeing anything. Now, network first isn't the only strategy. There's also cache first, which works in sort of the opposite way. Cache first is essentially saying, hey, I always want to get data from the service worker, but if that seems to fail, then rely on the network. Fastest is I don't care where I get my data from. If it comes from the service worker or my network, I just want it as fast as possible. Now, it makes the most sense to use cache first and fastest if you know the data in your app won't change. Because at the end of the day, you want to make sure your user sees the data as fast as possible. There's also the cache-only strategy where you only want the data from the service worker, and if that fails, you don't want to see anything. And there's the network-only strategy where you don't want any data from the service worker, you always want data from the network. Now, I have a hard time trying to understand why someone will set up a service worker and use network only, because it's essentially the exact same thing as not using a service worker at all. But I think somebody must have reasons for it, so it's there for a reason, I think. So again, using a service worker allows us for two things. It allows us to cache an app shell, as well as dynamic content. And the combination allows us to have faster repeat visits, because now we have the app shell always coming from the service worker, but it also allows for offline support, because not just the shell, we're also getting content being pre-cached. So can we use service workers right now? And Julian did touch up on this as well. Chrome, Firefox, and Opera all support service workers. With Edge and Safari, it's currently under development. And I think Safari, they just released the news a month ago, I think, or 3 weeks. And it's good news because even though it'll take some time for Edge and Safari to actually have complete service worker functionality, it's good to know that it'll actually be supported in all major browsers. So remember how when we were talking about H2 push, I mentioned it's not cache aware. It doesn't know what the browser's cache actually holds. Service workers can actually be handy here, because let's revisit our original scenario again. I'm on my mobile phone or I'm on any device, and I open the browser and I type something to URL bar and I press enter. If H2 push is enabled, the server can actually push some critical assets down. Now, if I reload the app again and I have a service worker, that content, let's say that critical resource was part of my app shell, it can now come from my service worker instead of going all the way to the network. So I'm not getting unnecessary pushes from the server. So not only are you getting a fast first page reload, fast first page load, you're also getting faster repeat visits. So whether you use a workbox whether you use a library like Workbox or another service worker library, or you want to write the logic yourself, pre-caching and resources can be extremely useful. So now let's talk about bundles for a bit. There's a really handy gist, and again, I'm sorry that the links are not showing, but there's a really handy gist that someone set up where he sort of used a number of different JavaScript libraries and frameworks, and he just generated hello world, essentially, output applications, and he just wanted to see what the bundle size was. And for some libraries and frameworks, it was 4 kilobytes, and others ranged all the way up to 200 kilobytes. Now, the reason why some are different is because I'm sure different frameworks have different things coming for it out of the box. But it's still something to think about, because I think as front-end developers, whatever tool we're using, we've come so used to actually building such client-side heavy logic, our bundles are getting larger and larger. So one way we can sort of work around that is to do something called code splitting. And the idea of code splitting is, and I will use an example of, let's say, I'm on a social network application. If I'm on the login page of the app, do I need the entire JavaScript bundle for the entire application? Or why can't I just get the JavaScript bundle specifically for the page I'm on? The idea for that is you essentially lazy load each of your routes. For every route or some of your routes, and the idea, when you're on a specific route, get the JavaScript you need only when you're there. If you are using Angular, lazy loading is built into the routing system. When you create separate modules, you can actually just add a load children attribute and point to that module, and it automatically knows to split that into a separate chunk. So when you're on that route, you'll only get that module loaded instead of getting everything loaded from the very beginning. Now, if you are using something like code splitting and you're thinking of lazy loading, it makes sense to sort of keep an eye on your bundle size from time to time. And there are tools out there that make it a lot easier. Webpack Bundle Analyzer, which I happen to love to use, is really nice because it actually outputs a super nice chart and shows you how parts of your bundle are actually larger than others. To give you an idea of saying, oh my God, Auth.js for Firebase here is massive, do I really need that? Another super useful tool that I actually stumbled on recently is bundle size. And what it allows you to do is it allows you to have your bundle size checks as part of your CI workflow. So you can say, hey, I want to add a threshold of 4 kilobytes, for example. And when someone submits a pull request, a message can say, hey, you've crossed that threshold. Or it'll just put a message saying it's actually 0.2 kilobytes large and master, be careful. So it allows you to keep an eye on your bundle size as commits and pull requests are being added to your application. Another super useful one, I should have had a screenshot here, is Webpack Dashboard by Formidable Labs. They had a dashboard in the terminal GUI, but they released one with Electron, and I've happened to just start using it, and it looks beautiful. So that's another way you can also keep an eye on your Webpack bundles. But again, the idea of lazy loading your remaining routes and code splitting can be extremely useful, because instead of having your entire bundle size when your user loads your application for the first time, and they may never even navigate through your entire app, they can only just get what they actually need, and when they actually move around, give them what they need incrementally. So the concept behind the purple pattern, again, it's not a specific tool. It's not black or white. It doesn't depend on the actual library or framework you're using. It's a set of different techniques that you can sort of think about. You can apply them incrementally and I'm sure some are going to be harder than others depending on your different context, but it's something to think about in that you can use some browser technologies and the technologies built into your framework in order to make sure the application loads fast and loads reliably. So when you're thinking of fast load times, the way I like to think of it is there's really two very important things that you want to consider. The very first one being first meaningful paint. And that's essentially the amount of time it takes for the user to see meaningful content on the application. The next one is time to interactive. It's essentially how long it takes for the user to be able to interact with your app when your JavaScript thread is actually settled. Now, I've seen a lot of stats online about time to interactive. I've seen some that say the average TTI is 16 seconds for a mobile web application or web page. And I've seen another one say for mobile web apps, it's 19 seconds. And it gets crazier and crazier the more stats I see. But I think it's just important to think about if it takes more than 5 seconds to load for your user, depending on whatever device you're on, keep in mind that a lot of your users just might give up. So Angular's actually done a lot in terms of trying to provide some progressive enhancements. So I showed you Workbox and how easy it is to actually include a service worker, but they're working on an Angular service worker library on its own. And the idea is when it's complete that you don't have to rely on a separate library, you can use something that's built in. The ahead of time compilation that they released recently as well has made huge changes and allowed bundle size to be a lot smaller. And they also released a new view compiler when Angular 4 was released in order to make sure your bundle sizes are going to be even smaller and smaller. So what I want to do is sort of just talk about a little journey that I did when I was looking into adding progressive enhancements to an Angular app. So I built a Hacker News client, I think, in the end of 2016. And the reason why I built this was I just really wanted to learn Angular. I had an Angular 1 experience. I really didn't know about Angular 2+. So I'm like, you know what? I think this is a cool app to build. I see Hacker News clients everywhere, so let me just do one. So when I actually launched the app for the first time and I uploaded it, a lot of people who noticed it were like, hey, why don't you try to make it load faster? Because a lot of people noticed that it was kind of slow. And initially, I was just using the browser, the Chrome dev tools in order to find out how fast it's loading, because it actually provides quite a lot out of the box. But there are tools out there that allow you to test web pages quite efficiently, and one of them is web page tests. And it's essentially a farm of devices in different locations. So you can test your web page, and I can actually show you. Probably makes more sense to show. I don't have Wi-Fi. Never mind. What is the Wi-Fi? I can always show that later too. Do you know what the Wi-Fi is? Barcelona.2060? Yeah. All right. Thank you. Oh, it's Barcelona uppercase? Okay, let's try it again. Sorry, I should have asked. If it doesn't work, it's okay. I can always show it later. That's fine. Don't worry. I can come back to it and try again. But what web page test actually is, it's a platform that allows you to test your web page in a lot of different devices. So you can pick, I want to test it on a Moto G4, and I want to test it on a 3G connection or emerging markets connection. And the reason why that's so useful is because we've become so accustomed to building large Angular applications or React applications and so forth on our MacBooks with super nice Wi-Fi. We don't think about how people are going to use our application with poorer devices and with worse network connections. Now, it's never as nice as actually testing it on your own. I think the best possible test for your web page is actually have an older mobile device and actually throttle the network connection. But sometimes it's not always the easiest way, so web page test is actually extremely useful. My Mac looks frozen, so sorry about that, guys. There you go. Nice. So what I did after a while, when I started actually trying to test performance for this application, I started using web page test, and I said, hey, I want to test Moto G4, and I want to test it on a 3G network. So when I launched the app for the very first time, it was with Angular 2.4.10. It was that specific version. And I was using the official Hacker News Firebase API. The time to interact was 22.55 seconds. And the reason why it was actually extremely high was because the official Firebase API, what it does is that it actually has a separate API request for every single story and every single comment. So when I actually loaded the application and checked my network requests, there was hundreds being fired for a single comment item or single story. And I knew that wasn't the easiest way. Fortunately, there are a lot of unofficial APIs that people built. And this one was super nice because it actually provided everything I needed in a single page with a single request. And I actually got the number down to 6.49 seconds. So now it's more of a reasonable territory because this application isn't massive. It's only a few screens and a few routes. The next thing I did was I switched to ahead of time compilation. Now, for a lot of people that don't know what that is, Angular originally used a just-in-time compiler. And the way that worked was essentially the compilation step happened as part of runtime when you load the application on the browser. So your compiler was actually being fed into the bundle as well. Once you switch to ahead of time compilation, and it's extremely simple to do so, with the CLI, it was essentially just adding an AOT tag. Now it's ready by default. But now what this does is it actually compiles your Angular components and templates on the build step, so by the time it loads in your browser, it doesn't need a specific compiler. That actually got the number down to 4.81 seconds. So now we're seeing some better progress. The thing after that I did was I added a service worker. And this was before Workbox was released. So Google had a separate library called SW Precache and SW Toolbox. Workbox is essentially just a rethink of those libraries. And that's why I think Workbox is really now one of the best ways to do so. But with the service worker, my time to interact on our first page load was 4.81 seconds. But on repeat visits, it was 2 seconds. And that was because the application shell was now cached. And notice how it's more than half. The time to interact was cut down by more than half just by adding a service worker. The next thing I did was upgrade to 4.0. And again, this just shows what Angular has been trying to do. Just their new view engine cut that bundle size down in order to have it down to 4.6 seconds. I then said, hey, let's lazy load my routes. And what I did was I essentially cut down the entire bundle size for the initial page from 132 kilobytes to 111. So it isn't a crazy jump, but all I just did was, hey, and I actually had a lot of contribution, a lot of help from contributors in the community. And somebody said, why not just have your user routes and your item comment routes as separate modules, so when your user actually navigates to your front home page, they don't need the JavaScript for that file. And I already noticed some wins. We're already looking down at 4.4 seconds. Now, 4.4 seconds isn't amazing. It isn't particularly, incredible for a mobile app to load that fast. But it's important to sort of think about with a lot of small techniques, I managed to cut the number down quite significantly. And again, that number is going to be severely affected by your entire bundle size. If my bundle size was 10 kilobytes, I'd probably be looking at a lot lower numbers. But even though I had a decent sized bundle, I just added some techniques and I noticed that I can get the numbers down quite a bit. So I hope you enjoyed this talk. I think I went 4 minutes over. My name is Houssein Djirdeh. Feel free to talk to me. I'll be here for a bit. And I just hope you enjoyed it as much as I enjoyed giving it. Thank you.
Thanks so much.